Express the following using sigma notation. So our first problem, we have 3 plus 5 plus 7 plus 9 plus dot 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 plus 99. Okay, so the first thing that you should recognize is that this is an arithmetic sequence. Okay, what that means is that you have a common difference. In other words, you have something that's being added each time. So you can pretty easily see which number is being added each time by taking the second one and subtracting the first. You get 2. Or the third one and subtracting the second. You get 2. So your common difference there is going to be 2. Okay, we'll call that our D. So what we need to first do after we realize that this is an arithmetic sequence and find out the common difference is we need to figure out how many terms. How many terms does this thing have? Okay, so sometimes it's really easy to see. You can just look at it and deduce what it is, but sometimes it's not. So if you want to figure out on an arithmetic sequence how many terms you have, you need to use this. A sub n equals a sub 1 plus d, that's our common difference, times n minus 1. Okay, n is the number of terms. That's what we're trying to solve for. We'll say a sub n will be our last term, and a sub 1 is going to be our first term. So in this particular case, on letter A, we have 99 is equal to 3 plus, what was our common difference? 2 times n minus 1. Okay, and if we solve that for n, now let's see, we get 99 equals 3 plus 2n minus 2 when we distribute that 2. So this and this become a 1, and then when we subtract a 1 over, this becomes a 98 equals 2n. N equals 49. 49 terms. Okay, so we have 49 terms. What that tells us is, well, let me back up. What we're trying to do is we're trying to write this in sigma notation, which means we need a starting point and we need an ending point. And typically speaking, you can either start at 0 or you can start at 1. If we start at 0, which is what we're going to do, we realize that when there's 49 terms, that assumes that you start with 1, 2, 3, 4, 5. If you start with 0, then your top number in the sigma notation has to be 1 less. If you start with 1, the top number is going to be 49. But if we start with 0, k equals 0, we get 48 terms. Well, not 48 terms, but that our top number is going to be 48. Our first term is the 0 term. Okay, so given that we're going from 0 to 48, then we need to figure out what our pattern is. Okay, this is an arithmetic sequence, so you can look at this thing and say, okay, it's going up by 2 each time, so that's going to be 2k. But we don't start at 0, we start at 3. Okay, so when we plug in this 0 here, this term goes away, right? That means our first term is what we're going to add here. Okay, that's the reason we started with 0, because it makes this a little easier to see. So your first term is always going to be this number so long as you start with k equals 0. And you can test this out. Just plug in like the fourth term. The fourth term should give us 9, right? So if you want our fourth term, that's k equals what? 3, right? So we plug in a 3. 2 times 3 is 6, plus 3 is 9. Okay, or you can plug in our last term, see if you get 99. So 48, you plug it in here. 48 times 2 is 96, plus 3 is 99. So it works. If you are told that you need to write this starting at k equals 1, you can do that as well. You just subtract 1. So we're starting at k equals 1, and that means that we're going to go to 49. That means that we need to subtract 1 in here to make that true, because we're going to be starting at 1, not 0. So it will be 2 times k minus 1 plus 3, and obviously clean that up a little bit. So that's equal to, from k equals 1 to 49, of 2k, and then distribute that, that's minus 2, so it'd be plus 1. Okay, and you can test to see whether that will work as well. Let's try our fourth term again. We did it last time. So our fourth term in this would be not 3, but it would be 4 this time, because we're starting at 1. So our fourth term would be k equals 4. We plug that in, 8 plus 1 is 9. Okay, so both of these work. It just depends on if you want to start at 0 or if you want to start at 1. All right, let's move on to the next one. B says we have 5 plus 12 plus 19 plus ... plus 61. Okay, so you can see that this is another arithmetic sequence because you're adding 7, assuming you keep adding 7 until you get to 61. So the first thing for B, figure out your number of terms. Okay, so that gives us, well, the formula, plus common difference times n minus 1. Okay, so we get 61 equals 5 plus a common difference was what? 7, right? And then n minus 1. Okay, so 61 equals 5 plus 7n minus 7 when we distribute. 5 minus 7 is negative 2, so you add a 2 to both sides. That's 63 equals 7n, n equals 9. There are 9 terms. Okay, so we know what we're going to do is start with k equals 0 to where? Remember, it's starting at 0, so it's not 9, it's 8. Okay, and then, since this is also arithmetic sequence, and you just say, okay, well, how much are we going up each time? That was 7, so 7k. And then where did we start? 5. Done. If you want to write it at k equals 1 to 9, it's 7 times k minus 1 plus 5. Okay, so that will give you k equals 1 to 9. Let's see, 7k, distribute this, that's negative 7 plus 5 is negative 2. Okay, you can put both of those in there to see if they work. Okay, and test them just like we did last time. Let's say we want the third term. Okay, so the third term on this one would be 0, 1, 2. It would be a 2. So plug in a 2 here, you get 14 plus 5 is 19. That's what is there. Or if you use the other one, our third term here would be 1, 2, 3. So 21 minus 2 is 19. So it seems to work. Okay, let's do C. Looks like it's the same basic deal on C. So let's just go ahead and write it down. We get 28 equals 4 plus the common difference of, it's going up by 2, 2 times n minus 1. Okay, so that gives us 28 is equal to 4 plus 2n minus 2. 4 minus 2 is 2, added over, or subtracted over. So 4 minus 2 is 2, you subtract it over, you get 26 equals 2n, n equals 13. There's 13 terms. Okay, so we will go from k equals 0 to 12. And we're going up by 2, so 2k plus our first term was 4. Okay, or k equals 1 to 13. 2 times k minus 1 plus 4. K equals 1 to 13 of 2k, let's see, whoops, that is a k there. 2k minus, let's see, that's minus 2 and plus, so it's plus 2. 2k plus 2. Okay, and last, this one. This one's a little different. Okay, so we're going to have to look at this slightly different. We can still see the number of terms. Let's analyze this thing. So we got 2 different numbers that are being multiplied on the bottom. It goes from 1, 2, 3. So that one's going up by 1 all the way to 49. Okay, so we can see already that if this one's going up by 1 each time, then we have 49 terms. Okay, you can do the same thing here, 6, 7, 8, 9, 10, 11, 12. So it would be 54 minus this term, which would be, let's see, 54 minus 6 plus 1 would be the 49 terms. So there's actually not, or 48 terms. Okay, so we can just do that really quick using the same method. Just pretend that it's just 1, 2, 3, 4, 5. So our last term is 49 equals, our first term would be 1. I'm just doing the 1, 2, 3, 4, 5. Plus our common difference of 1 times n minus 1. Okay, so 49 equals 1 plus n minus 1, so n equals 49 terms. Okay, so we have 49 terms in this thing. All right, and we need to figure out how to write this because it's a little different. So we have two things going on. We have one thing that is increasing by 1 each time and another that's increasing by 1, but it starts at 6. Okay, so remember we have 49 terms, so we're going from k equals 0 to where? 48. Okay, so we go from 0 to 48, and it's 1 over, because the 1 on top doesn't change. And we'll say our first term, since our first term needs to be a 1, we need to do k plus 1, because remember we're plugging in a 0. Because we plug in a 0, we need our first term be 1. Okay, and then since we're plugging in a 0, but our first term is 6, we need k plus 6. Okay, so that is it for if you are k equals 0. Now let's do for k equals 1 as we've done on all the other problems. So k equals 1 to 49. Okay, and that would be, we just subtract 1 from each one of these. So we substitute in a k minus 1, which basically means we subtract 1 from each one of these. So it would end up being 1 over, I'll write it out, k minus 1 plus 1 times k minus 1 plus 6. Okay, and that will end up being k equals 1 to 49, 1 over k times k plus 5. Okay, so that's two ways of writing the solution.